Hello, I'm Todd Taylor, BICSI President, and thank you for joining us for this ICT Field of Vision presentation, Is It Time for Fiber? A horizontal fiber architecture for buildings and campuses. Today's presenter is Rona Davis. Rona has been in the networking and telecommunications industry for over 24 years. She has been with CommScope for over 14 years and held positions in sales, channel, and product line management. She is currently on CommScope's strategy and technology team for campuses and buildings. Before CommScope, Rona worked in the design and construction of telecommunication networks and in wholesale distribution. Ladies and gentlemen, please welcome Rona Davis.
Hi, thank you, Todd. Again, I'm Rona Davis. I'm on the strategy and technology team for buildings and campuses at CommScope. Today, we're going to talk about horizontal fiber for buildings and address the question, is it time for fiber? So we're going to cover three areas today, starting with a background on horizontal fiber in the building. Then we'll cover the most common horizontal fiber architectures. And then finally, I'll provide some recommendations for your horizontal fiber project. So let's get started. So a lot is happening in the network space right now. Density, IoT, cloud, edge compute, blockchain, artificial intelligence, augmented reality, virtual reality, just this diversity of devices that are coming on to the network, from low bandwidth, low power devices like sensors, to high power Wi-Fi access points, PoE powered digital displays, high bandwidth augmented reality interfaces, and enhanced multi-application video cameras. Just this multitude of game-changing technologies that will alter our network landscape forever. And networks are no longer just about bandwidth. The network is responsible for powering many devices in the building. And as the network footprint grows, we must keep sustainability in our sites. What we install needs to last and have a lower embodied and operational carbon impact. So with all of this exciting change happening, we have to ask the question, is it time for fiber? Now, fiber in the horizontal space is not new at all. In fact, fiber to the desk standards were released not long after our first category cable standards. Fiber's intrinsic value of nearly unlimited bandwidth to the workstation has been well documented for about 30 years now. So why don't we all have fiber to the desk today? Well, there's a few reasons for that. Initially, fiber optic terminations were more complex. They were time consuming and they left little room for error. And while fiber optic cables can be pulled with quite a bit of force, their tensile strength really is unmatched. Fiber cables are more sensitive to crushing, and original fiber cables didn't respond well to sharp bends that you often see in the horizontal installation environment. Now, secondly was electronics. Fiber NIC cards were available, but they were pricey, and they weren't nearly as available as the RJ45 copper NIC cards that were shipped with PCs. Additionally, the SFPs for switches were also more than the copper PHYs. This made fiber to the desk implementation more costly, even if you weren't pushing more bandwidth to the desk. But the fatal wound to fiber to the desk was PoE. Once we could use copper cables to provide both bandwidth and power to our devices, fiber was really no longer that nice to have at the desk level. In some ways, PoE made fiber to the desk a legacy or an antiquated technology. So what's changed? Well, hybrid cables that bundle fiber and copper power conductors have reinvigorated fiber in the horizontal. Addressing the power and data in a single medium has helped fiber to the desk and fiber to the room technologies grow in adoption recently. Now, you can't switch out a fiber cable directly for a PoE cable. Powered fiber cable does require different hardware and special design considerations that we're going to cover next. But hybrid cables present a viable solution for our bandwidth, power, and sustainability needs as we architect our networks for the future. So there are three primary components to a powered fiber architecture that make it unique from a typical fiber or copper install. Power sourcing equipment, hybrid power fiber cable, and a DC power input at the endpoint device. The power sourcing equipment is typically a DC power supply, 48 to 60 volts, class 2, low voltage. The power conductors of the hybrid cable terminate to the DC power supply. Now, an intermediate cross-connect can be introduced here if desired. Now, your endpoint device must have a DC power in that is within the range of your DC powered supplied voltage and current. Typically, this is 48 and 57 volts nominally and less than 100 watts to meet self-class 2. Your fiber connections are typical, but you need to make sure your endpoint device can accept a fiber connection. Now, as you can imagine, endpoint devices that are DC powered with fiber connectivity are limited. The standard for low voltage network devices is the RJ45 with PoE as the power source. But more are coming available, including some compact network switches, some PON ONTs, and there are DC powered fiber connected wireless access points and security cameras. So let's take a moment to just take stock. Fiber in the horizontal definitely meets some key objectives around budget, power, and bandwidth. Solutions available today simplify horizontal fiber installation, and other key attributes like a smaller footprint and a growing number of fiber and DC powered devices available has increased the viability of fiber in the horizontal space. Is it time for fiber? It just might be. Fiber offers the most bandwidth and future-proofing for your network. Issues that slowed early adoption of fiber to the desk and fiber to the room have mostly been mitigated through faster, more reliable installation solutions and bend-insensitive fibers. Hybrid power fiber cables allow us to address the growing power demands of the network. Remote powering of devices has significant benefits, from reduction of local power circuit installation costs to utilization of centralized UPS and battery backup systems. And fiber networks reduce the overall materials in your network. That first tenet of sustainability is to reduce. Now, the longevity of fiber networks increases their sustainability by reducing rip and replace and forklift upgrades. Now, fiber optic networking, when implemented correctly, is a win. So now we're going to talk about fiber architectures next. So we'll begin with centralized fiber optic networking, or point-to-point fiber. Now, this is the original and the oldest fiber architecture to support fiber to the desk. Now, in this architecture, you install 2 strands of fiber from the main equipment room to your endpoint device. Now, you can install single mode or multi-mode fiber, allowing you to take advantage of lower cost multi-mode 10 gig optics for runs that are under 550 meters. Remember, your endpoints need to have a fiber in connection, or they have to have a fiber to copper transceiver. Now, if you don't want to run home run cables all the way back to the main equipment room, you can consolidate fiber cables by adding a splice point in a TR or in a ceiling space, and then running a single high count fiber trunk cable from the splice point back to your main equipment room. Now we're going to look at an enhanced version of this architecture that adds remote powering using hybrid power fiber cable and DC power supplies. Now, the benefits of remote powering are reduced electrical installation costs. There's no local AC power that is needed at the endpoint device. And then utilization of a centralized UPS or power backup circuit. Now, there are distance limitations on the power conductors. This is important to remember. The gauge of the power conductors and the power required will dictate how far you can go before you need a DC power supply. If your run exceeds the power and the distance thresholds for your cable, you can add a DC power supply in a telecommunications room or an equipment room, even in a ceiling enclosure. And you can still take your fiber cables all the way back to your main equipment room so you don't have to locate network equipment in your telecommunications room or in your consolidation point. Now, you can. That is an option to locate your equipment in your telecommunications room. So, and this is what that looks like. Now, you have power distribution in a TR or other equipment room or that ceiling enclosure. You consolidate fiber cables into a single fiber trunk with a splice point so you can distribute power from that telecommunications room while running shorter powered fiber cables to the endpoint devices. The architecture you choose will likely be based on distance, availability of power, and whatever your power backup or UPS strategy is. Now, I think a key takeaway here is that powered fiber addresses some systemic issues around density, IDF crowding, and reliable power distribution, but it's still remarkably flexible. Now I'm going to cover PON architectures. Now, passive optical networking was created to solve a problem for service providers. Service providers had fiber in the streets, but not enough to give everyone fiber to the home or to their business. And to install fiber cable all the way back to the central office just wasn't feasible, as it required miles of new fiber to be installed and disrupting streets and getting access to right-of-ways. PON provided an excellent solution by introducing passive optical splitters at the pedestals in the street where the fiber was located. Now, the passive optical splitter splits the fiber and its signal without the use of power. From the OLT, the optical line terminal, this is the system's head end, a signal is sent along a run of fiber. When it reaches a passive optical splitter, mirrors and glass in the component split the light into multiple strands. From the splitter, you run a single mode fiber optic cable to an ONT, the optical network terminal, sometimes called an ONU, an optical network unit. Now, the ONTs are typically equipped with multiple network ports, including PoE and sometimes cable TV ports, as well as telephone line ports. Some ONTs are also Wi-Fi access points. Now, while PON was developed to allocate fiber bandwidth on a shared network for service providers, PON can and is used in commercial buildings. The key difference in PON networks is that injection of the passive optical splitter. It allows you to use less fiber strands, which was critically important to service providers. It's not really as much of an imperative for the typical enterprise customer who is running fiber cables just feet, not miles. And generally, commercial customers have control over their pathways and spaces in their buildings and on their campuses. Now, the typical splitter configurations are 1x16 and 1x32. And it only requires a single strand of fiber at the splitter and at the ONT, unlike active Ethernet, which uses two strands of fiber, one for transmit and one for receive. In the PON architecture shown here, a fiber is installed from the OLT, that's the optical line terminal, to an IDF. This could also be a ceiling enclosure or a telecom enclosure. The fiber is connected to a fiber splitter, and in this case, it's a 1x32, and then individual single fibers are ran to the ONTs. Now, you can also support PON architecture with remote powering using hybrid power fiber cables. It looks a lot like what I showed you before with centralized fiber optic networking from a power perspective. There's really no difference there. The difference is in the way that the fiber cable is split and or distributed. Okay, now let's get to our recommendations. CommScope has been around for some time, and we've seen many technologies come and go. Our goal has always been to ensure that the infrastructure we recommend to our clients will last well beyond the current technologies or applications. Building infrastructure is meant to be there through 3 to 5 technology refreshes, and it should last 15 to 20 years minimum. This is why we implore you to choose architecture over application. Your network infrastructure needs to outlast current applications and technologies. Now, while fiber provides investment protection, how you architect your fiber infrastructure can have serious implications on its ability to support future applications, technologies, and network speeds. Be wary of solutions that ask you to sacrifice your long-term infrastructure for a short-term cost reduction. The reality is that cable installation, if it's copper or fiber, is very labor-intensive. You're better served to put the adequate amount of cable in today and not pay for rip and replace or expensive cable additions in the future. And switching out equipment, that's pretty simple. Ripping out or adding cables is highly disruptive and costly. Now, if you are evaluating PON, there's a few things to understand. We've been talking a lot about the architecture, right? Well, PON is a technology, but PON is also an architecture. PON optical splitters require PON optical equipment to transmit and receive a signal over that split fiber. This means that if you install optical splitters in your fiber spans, you will always require PON equipment to use that fiber. That is, unless you remove the splitters and then install new fiber to accommodate the different technologies. Now, PON is a viable solution for enterprises, but you need to be aware of how architecting your cabling infrastructure exclusively around PON technology can limit its use in the future. PON technology does not require a PON architecture. You can utilize PON without limiting your ability to change or adapt to another technology in the future. Another thing to consider when you're evaluating and when you're planning your network architecture is future-proofing. What you don't want to do is tie yourself to a solution that will not be able to keep up with the latest available market technologies. Speed and bandwidth are especially important because speed and bandwidth are literally what enables more competitive business processes and applications. A business network is integral to its ability to remain competitive. So when a technology comes available that can improve your business processes, improve employee satisfaction, increase productivity, or help you meet your objectives faster or easier, you want to be able to access that technology without having to upgrade your entire network. So as you can see here on the slide, traditional Ethernet leads the market in speeds and feeds. Now, as to our specific recommendations, our field application engineers at CommScope can help you to develop a detailed bill of materials specific for your horizontal fiber project. But we do advise that you start with a few guideposts. First, install 2 strands of fiber to each endpoint. Installing a single strand will literally leave you stranded. 2, don't take the fiber alone. Bring the power with you. Remote powering via powered fiber cable is a great way to leverage centralized battery backup, reduce electrical installation costs, while taking advantage of fiber's extended distance capabilities. Now, additionally, if you choose PON for your network, we recommend locating your optical splitters as close to the OLT, that optical line terminal, as possible, preferably in your main equipment room. This will help you to avoid any forklift or rip and replace cable scenarios in the future. Now, our final recommendation. BICSI and the TIA are great organizations that have done a fantastic job of developing and supporting standards for our industry. Standards and training that promote reliability, interoperability, and confidence in the technology. Now, I've been in the industry for 25 years now, and it's more important than ever that we continue to promote adherence to standards and the underlying values of structured cabling. We need to advise our clients and our stakeholders of the consequences of poorly planned infrastructure and the benefits of a well-planned and executed structured cabling system. Now, if you follow these few simple rules, You can support multiple technologies. You will ensure you have the full bandwidth of every single fiber strand available to you when you need it. And your critical network devices can be supported by your power backup systems. So no more headaches maintaining local UPSs, and more assurance that your critical devices will be up and running in the event of a power failure. So that's all that I have for you today. I hope you enjoyed the message, and I hope that it left you with something to think about. If you have any questions or if you'd like to talk more about infrastructure, please reach out to me on LinkedIn. Thank you and have a great day.